Hi everyone, good afternoon or evening, whatever. It's in the middle. So I hope you all are ready and let's begin solving a few more questions today, continuing the test prep session, right? The interview session we'll conduct tomorrow, the second interview session. For now, let's keep going with our third test prep session. Today I've got, because every time we overshoot, right? Every time we overshoot our time, so we take more than 2 hours of a session. So today, to make it much more easier for you guys, so that you guys are able to attend it completely and don't have to go and later watch the remaining of the session, I have made sure that I'll be only covering approximately 14 to 15 questions so that we are on time and you can attend the session completely. And this way it will be helpful for you so that you don't have to worry about watching the recordings and everything, right? You don't have to come back to the stream and watch it again because after 2 hours or maybe after 1.5 hours or something, you had something urgent to do and you had to leave in that particular case, right? So I've made it only for 15 questions today. We'll be solving some interesting questions on Python and particularly machine learning. And from the next particular test prep session, I'll be beginning also the aptitude part. We'll be covering probably 5 to 7 questions every time from aptitude. The questions which are more important, the patterns which are very often seen, and the questions where you all can make mistakes. So we'll be solving those from the next particular session. So now let's begin by solving our first question. I'll be presenting my screen. And I'll be starting with the timer. All right, so 2 minutes to begin with this question. Please take your time. You can start solving this question. It's a very common question. Like, it's a mix of few inbuilt string functions, but these kinds of questions are very common. All right, 1 more minute approximately. Okay, 30 more seconds. If you guys have got the answer so far, please put the answers. All right, so the time is up and now I'll be solving the particular question. Yes, Harsh, that's the correct answer. That's the right answer. Let me now start solving it. Good job. So it's a pretty simple question. It's just the 3-4 things you have to do together all at once. Apart from that, there's not much anything to this particular question. So text.strip is basically, we can see there are white spaces over here. Text.strip removes the trailing and the leading white spaces, right? So as simple as that, you just need to do text.strip, and after that, your trailing white spaces and your after that white spaces are completely removed. So if there were white spaces here as well, they've had completely gone, because strip in itself is removing the white spaces from both left and right side. There is one common function called lstrip. This particularly removes the white space from left side. rstrip, this particularly removes the white space functions from right side. Then if inside strip you have something mentioned, for example a or let's say b, then it will remove the character a and character b if they are present on the left and the right side, right? So these are the important things you need to know about the strip function. So after this, what will happen is your white space will gone. This will become, hey there, welcome to Python 4.2 tutorial. Dot lower will make everything lower. So this string will convert to, hey there, welcome to Python. There's a space in between, right? 4.0 tutorial. Then after this, from here, you replace tutorial with course. So pretty simple. You just remove this and put a course over here. Then you do a dot split. So if there is nothing mentioned in a split, that means a white space splitting is there. So very important point to understand. One more I want you to understand is that if you say, let's say there is a string which is A, B, C, D, E, F. In case you say string dot split, then what you will get is A, B, C and D, E, F, a list out of it. You will get a list out of this, right? But if you say list and you put the string inside this, then what you will get is A, comma, B, comma, C, comma, white space, comma, D, comma, E, comma, F, right? This is what you will get. So this is very important to understand how the list and the string function or string dot split without anything in between. There's nothing in there. Splitting is being done on white space. That is what the Python assumes, and it makes the split. Right, but in case if you were having a list with list dot string, if you would have done, you would got A, B, C, D, E, F. So this is very important to understand. This is sometimes where I see a lot of people making mistakes when it comes to online tests, right? And strings in strings, commonly this is a trap where generally students are caught into, right? So now that you have a split, you take the two. So you have hey there, after there is no space, so there and exclamation mark in one, welcome, then two, then Python 4.0, then course. So from here you will select 0, 1, 2, which is nothing but welcome, right? Which is nothing but welcome. So replace 4 and 4th. So is there a 4 in this particular thing that you will replace? There is no 4 in this, so you don't have to do anything. You can just move forward and do capitalize. What will capitalize do? Capitalize will basically capitalized in the proper English. How do we capitalize? We capitalize only the first one, the first alphabet of a word. So we'll do that. We'll capitalize the first alphabet of a welcome, of a word welcome. We capitalize it, we get welcome, and then we'll find P. Is there a P present in this? There is no P present in this, and hence if a find function does not find a particular any particular substring or a character that is looking for, if it does not find in the in the string that you are searching in, so if welcome dot find P is not able to find our small p in this returns -1, and hence answer is -1. A pretty simple question, but a few points that I talked about while we solved this question are important that you understand. For example, this list and this different strippings that exist, right? These are most of the times you will see a different kind of strip function, a different kind of, else strip, r strip would be there. Find function, instead of just mentioning the substring that you need to find, they will provide you the starting index from where you need to find, right? So not from the start, but from a different starting index where you need to find, right? So these are a few important things that you need to take away from this particular question. Okay, now let's move on and solve the next particular question. Let me quickly wipe down the screen. So you can see -1 is the correct answer. Now let's move on and solve this particular question. I'll give you 120 seconds to solve this. These kind of questions are very common, very, very common in specifically data science tests. And also these kind of questions are very common in those data analyst companies where the test contains technical questions, because as we all know by now that it's not mandatory that every data analyst company will ask you questions based on technical knowledge, right? That doesn't happen often. So, but whichever company asks you Python questions, you will find these kind of questions there. But in data science roles, in tests conducted for data science roles, these kinds of questions are very, very, very common. Because as you can see, it's based on nothing but comprehensions. They could have made it even more tough by putting the filter function directly in the comprehension itself. It could have been made even more tough. I don't know the answer either, Rajdeep, so far. Even I'm not sure about the answer. All right, I think 30 seconds have been provided to all of you. There's not much more time that you guys would need to solve this question. 30 seconds are what is left. All right, Shivangi, correct answer. Rajdeep, correct answer. Pretty good, guys. All right, now let's solve it together. I think enough time is 120 seconds for more than enough for this particular question. Yes, correct, Harsh. The answer is C. All right, now let's solve it. So what exactly we need to do? This is the raw data that is given to us. This is some kind of a function. As we pretty cool understand what is this function doing. This function is saying if n% 3 equal to 0, then I will return true. Otherwise, I will return false. Basically, it is returning nothing but a boolean, right? And this is n% is nothing but a modulo, right? So if the remainder when divided by 3 is equal to 0, then I will return true. Otherwise, I will return false. This is what exactly the filter function is doing over here. Pretty simple, pretty easy to understand if you understand this equality and these operators. Right, now x raised to the power 2. Now what we are doing over here is, as you can see, this is a list that we are creating. This is a list we are creating, and how we are creating it? We are creating this list using another list. Rather than entirely writing this in terms of different way, we could have also written this as in for x in raw data, if filter function of x and x% 2 equal to 0, then you need to see if x greater than 5, then process list, whatever the name is, dot append x2, else process list dot append x into 2. So this is the simplest comprehension that you have written down in probably one line. Is this exactly? There's nothing else to it. Now it is important for us to understand how the list comprehensions work, right? When there are 2 to 3 times if and else, students get a lot of confusion. What does this if means? What does this if means? Right? So whatever I've written down is just to explain you the entirety of how these comprehensions work. So basically, now I'll be explaining you that this particular if is used for filtering. It is used for filtering, as you can see over here, right? Directly after for, whatever if is coming, it is used for filtering. Whether this data will go into the final appending positions, the final code snippets where the appending will take place into this process list, whether this will go into that or not is dependent on this if particularly. So this if will do the filtering, and then this if and else will decide what value will you use to append into the new list, right? So this is how you can write the entire code. So as you know, first you will do the if block over here, the filtering one will come over here. Then when you will come to the appending side, you will put all over that over here in this particular block, right? This is how you can write your entire comprehension back to the normal Python code. Now from here, one more thing is important is that, okay, I think we've covered everything. I've already told you about the filter function. So now let's understand what will be the answer. So 2 will go into this, 2 will go into filter function, but it will not pass because when 2 is going into here, so x will be first 2. So when 2 is going into here, the filter function will say %3 equal to 0 is false. So you will not get that answer. Then 3 will go into it. 3 will say, okay, filter function will say it is equal to 0, right? That will come as the 0, but x percent 2, x modulo 2 will come not as 0, and hence this will not go down. Filtering will remove it. Then we'll go to 5. 5, as you understand, both 2 and 3 do not divide it perfectly. You will not get a remainder 0. Then we move to 6. 6 is both a multiple of 2 and 3, and hence it will pass through the filtering. After it has passed through this filtering, it is greater than 6. It is greater than 5, sorry. So the impending will be 36. Then 8, again it is not divided by 3, but only 2. This is not divided by 2, but only 3. This is not divided by both of them. This is divisible by both 2 and 3. This will pass by, and then because it is greater than 5, you will take a square of it. Square of 12 is nothing but 144, and the answer comes out to be C, 36 and 144, right? Right, now moving on to the next question. If you have any doubts, please feel free to let me know. Any doubts, please let me know. This comprehensions are very easy in a few companies particularly. For example, one second. Yeah. So as you can see, C36 144 is the correct answer. Now let's move on to the next particular question. I will give you 60 seconds for this. It's a pretty simple question. Okay. 60 seconds. I'm starting the timer now. So these kinds of questions, what we solved earlier, the comprehension questions are, yes, Harsh, just have to check multiple of 6. That's it, right? That's it, obviously. So these kind of questions are very important, right? And in specific companies, like when it comes to data science roles, especially for companies like InfoEdge, it's asked in interviews, it's asked in even in your online assessments. Other companies have been also recently asking this type of questions when it comes to your online assessments. For example, Ola, Uber, I've seen a few questions from the list comprehensions, set comprehensions, dictionary comprehensions coming in place, and hence making this a very important topic when it comes to Python. All right. Please provide me with the answers. It's a pretty simple question. You don't even have to solve it with using pen and paper. Do we have any answers? That is the wrong answer, Harsh. So as we all know that this is entirely wrong answer. If you would have seen my first test prep session, we had talked about tuples in there. And in that particular session, I had mentioned that tuple in itself cannot change. But guys, this is a list object. A list object can change. It is a mutable object. Inside a tuple, if there are mutable objects, they are free to change. Tuple is immutable, definitely. But inside a tuple, if there are mutable objects, they can change. And hence, t0.append will do what? Will append 50 to this. Dictionary will become 30 and 40. Then t160 means I'm assigning 60 as the key, 70 as a value to my dictionary. So this will assign 60 to 70 in my dictionary. Then t0.extend 80 and 90 will do what? Will nothing but when we mean by what we mean by extending is basically you add both to the last. You add the entire list, whether there are 2 elements, 3 elements to the last. Right, Manas? That is the correct answer. So 30, 40, 60, 70. This is the correct answer. Option number A is the correct answer. All right. So as a revision question, I had brought this up this time, and I hope that you guys go back and watch the series. This particular series, test series, you watch the lecture 1 of it and get to the correct answer, and don't make a mistake in this anytime again. Even if there was a set in this, that set being a mutable object could also be altered. Even if there was a let's say a dictionary already is there, list is already there, these things can change. If there was a string integer, those things cannot be changed. If there was another tuple inside a tuple, that cannot be changed. But if there are mutable objects inside a tuple, those mutable objects can change. And hence, option A is the correct answer. Now I'll move to the next particular question. I'll clear the screen and hide this particular tool. Moving on to the next question. Before that, we can see that A is the correct answer for the question number 3. All right, another interesting question based on the memory blocks. I'll give you 60 seconds to solve this question. Please come up with answers, everyone. And I hope you're making a note of what things are you making a mistake at, so you can go back and read these in depth. What is the answer for these, everyone? An interesting question based on copying on memory blocks and all that. We have been doing this a lot. These are very important questions. A is the wrong answer. Rishabh and Shivangi. 10 more seconds to go. A is the wrong answer, guys. All right, time's up. Now I'll be solving it. So whenever we are saying your matrix is 0, 0, and inside this you're saying multiplied by 3, basically you're doing multiplication of 3, what is happening is you basically are saying that, hey, don't just stop here. What I want you to do is I want you to, inside this, I want you to replicate this 3 times. This is understandable so far to all of us, right? This is understandable to all of us so far. And that what we know, what we are doing is a correct thing. This is correct. But what exactly are these listed to? So let's call this L1, let's call this L2 and L3, right? Too many L's. L's for the W, guys, right? So L1, L2 and L3 are each pointing to a same memory block, which is extended. Your 0th index is extending to 0, and your first extending is another memory block which is having 0. So guys, this is how when you are doing multiplication, which is nothing but you are replicating the you're replicating the elements of the list by n number of times. You are not creating new memory blocks for each list. Each list is assigned or is referenced to the same memory block, right? It is reference to the same memory block. And now what will happen is, so when you are saying matrix 0, 0 is 9, that means this 0, the 0th index, which is nothing but my list 1, inside this list 1, I'll go to index 0, and the memory block will now be, this particular will now be pointing to the memory block of 9. This 0 will exist somewhere, right? Actually, this 0 already exists. It was initially pointing to this, but now instead of pointing to this 0, it will start pointing to a 9. It will summon a new memory block, and inside this memory block, it will put the integer 9, and it will start pointing to the 9 rather than pointing to the 0 where it was initially pointing to. And after this, when you print it, now because each of the lists is referencing to the same, so the answer is 909090, and then C is the correct answer. Right? So again, guys, question that I took today for revision. A lot of questions I took today just for revision purpose, because a lot of questions we have done so far in the first 2 test prep sessions were actually very good. So I thought let's revise 2 to 3 more of these topics, because these are very important, and these are the places where students get stuck the most, right? All right. So now I'm gonna clear the screen, hide the screen brush. Let's move on to the next particular question, everyone. And let's, as you can see, C is the correct answer. I almost forget every time to show you the answer on the screen. All right. So this question, let me just have a look. Okay. So it's again a very, very pretty simple question. 60 seconds is what I will give you based on the axis concept. If you know it, it's simple. If you don't know it, then it's 50-50 to the correct or the wrong answer. All right, what is the correct answer for this, everyone? The answer should have been already here so far. Question based on access and numpy. np.sum, we all know it's just doing a summation, right? Just adding up things. But how is it adding is an important question. Is it adding all the elements in individual lists, in the nested individual lists? Manas has said A. Correct. Arts and Manas, A is the correct option. Very good. So when it comes to numpy arrays and the access concept, let's just make it look a little better first. Making it look a little better will give us much more confidence and understanding of what we want to do. So what we'll do now is, these are columns, these are the rows. You can also visualize it, right, in terms of an Excel sheet or data frame. So whenever access is equal to 0, that means operations are performed column wise. So here access is 0. We'll pick up this column, sum these all up, 25 plus 15, 40, 40 plus 5, 45. And then the second column, 10 plus 20, 30, 30 plus 30, 60. This is the answer. If access was in terms of 1 and the answer, then you would have to do it row wise. When it comes to row wise, you would say 5, 10, 15. Then you will say 5, 15, 20, 35, 25, 30, 55. And this would be your answer. Right? So pretty simple, I think, and easy to understand what this access concept is in NumPy. And you guys need to remember this. Access 0 means column, 1 means rows. Now moving on to next question. If you have any doubts, feel free to let me know. So now you'll also be seeing, because we have covered good amount of questions on Python already. Yes, there are many more that we will cover, but from the upcoming sessions, this was just a hint that yes, we'll also be deep diving into more on NumPy and pandas type of questions and covering those as well, right? Okay, next particular question, we can see answer A is correct. Now moving on to the next particular question, everyone. All right, 60 seconds for you guys. Oops. All right, if you have seen the answer, try to think about it. If you have not seen it, well and good. 60 seconds is what you have. Try to solve this particular question. And if you have seen the answer, try to answer in terms of approach rather than just throwing out the answer to me. I'll have a glass of water by then. 1 second, hold on. Keep solving it by then. All right, I'm back, everyone, and I hope time is up. I hope you have come up with answers. Just give me 1 more second. I'm sorry. I have to just reply one important message. Just give me 1 second, everyone. All right, cool. So what is the answer? Even I don't know. I have not solved it. Right, let's come up with the correct answer. So how many times the model will occur how many times the model training will occur, sorry, when you perform grid search CV on KNN, with K for KNN having values as 5, 10 and 20. So these are the hyperparameters for K, and the distance metric is given as Euclidean distance or Hamming distance. Also K for CV, K for cross validation is 4. So this is what the information has been provided for so far. So what happens in grid search first? So to understand what happens in grid search is that you take a Cartesian product of all the hyperparameters that are provided to you. Here you provided 2 hyperparameters, you take a Cartesian product with it. First combination will be 5e, second combination will be 10e, next combination will be 20e. Then you will have 5nh, 10nh, 20nh. These particular combinations is what you will have, right? Now for each of these, your model training will happen. First for this, second for this, third for this, fourth for this, fifth for this, and sixth for this. But this is not just it. This is not just it, guys. Now let's understand what extra thing there is. So this is grid search CV. What will happen is the model will be trained on all these hyperparameters, and the hyperparameter which gives you the best validation metric will be chosen, the hyperparameter combination basically, which will be chosen as which will give you the best metric for validation, will be your final metric that the grid search will provide you. But grid search does not use a holdout validation approach. So what is an holdout validation approach? A holdout validation approach is the worst approach for testing your model, for validating your model, where you divide your data into train and validation. This is the worst approach because you have a constant same training data set, a same validation set, and now the problem can be that some of the patterns which are in training data are not present in validation. So on these patterns, your model was performing bad in training data, but because they are not present in validation, so you don't even understand that, hey, is my model performing good on these patterns? You will never come to a conclusion. Another problem will be that some patterns may only be present in the validation set, and not present in the training set. If they are not present in the training set, then these patterns, how will the model learn if they are missing? The models will not learn those, and you will never understand whether your model is actually performing good on the entire data or not, and hence you use k-fold cross validation. In k-fold cross validation, what do you do? In k-fold cross validation, you divide the data into k sets. So let's say our k is equal to 3, you divide the data into 3 sets. Once your data is divided into 3 sets, you will say, I will use k minus 1 sets for training, and I will use 1 set for validation. And I will make sure that my validations, all the groups act as validation set at least once. I will make sure that all these groups that I have created when k is equal to 3 will act as validation set as once. So what will happen is, first the training will happen on 1 and 2 group, or on the group 1 and 2, that is fold 1 and 2, right? And then you will get some error. Your model will learn from these errors and end. Then you will use third group to get the metric for validation. This is the first step that will happen. In the second step now, what will happen? In the second step now, your 2 and 3 will be used as training, and you will get out, your errors will be used for the model training. And one training data, one data of the fold will be used as validation data, and you will get a validation metric. In the third step now, 1 and 3 will be used for training. In the third, 1 and 3 will be used for training. And when 1 and 3 are being used for training, then obviously 2, which is remaining, will be used for validation. So when k is equal to 3, you're training the model 3 times. When k, basically for any k-fold cross validation, you're training the model k times. I hope this is clear, that you're training the model k times. Now let me clear the screen. So we have understood that you are, one second, that, okay, I put the answer by mistake, but that's completely fine. So when k is equal to 4, and when you have hyperparameters a cross b, which is in our case k cross d, which is 6. So for each combination, there will be k-fold cross validation. So basically, for your all these combinations, let's say 10 and Euclidean, 20 and Euclidean, 30 and Euclidean, then 10 and Hamming, 20 and Hamming, whatever these were, right? 5, 10 and 20, sorry. I took as 10, 20 and 30, but my intention is just the same, right? So 30 and Hamming. Now what will happen is, you will train 4 models here. 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 You will train 4 models here and 4 models here. So the answer comes out to be, this is wrong. This is wrong, I'm sorry. So the answer comes out to be 4 plus 4 plus 4, which is, all these are basically added. So it should be actually 4 cross 6, 4 times 6, which is nothing but 24 models will be used for training. So Harsh got it correct. That's pretty good. Manas got it correct. And Rishabh also got it correct. Good job, guys. So these are the number of models that you will be training. All right. Now let's move forward. And hide the screen brush. So guys, I hope this is clear that it's written 4 raised to the power 6, but it actually is 4 multiplied by 6, right? It shouldn't be 4 raised to the power 6. I think it's a typo. All right. So it should be 4 multiplied by 6, that is 64. All right. And in other terms, this is nothing but the number of combinations from different hyperparameters. So let's say you have a number of terms for first hyperparameter, b number of terms for second hyperparameter, then it is a cross b cross k. Let's say you have 3 hyperparameters, then a cross b cross c cross k, right? All the multiplication you will do. It's pretty simple. I hope now you have understood the logic and how you will come to an answer. Now let's move on to the next particular question. What are the problems with k-means clustering? More than one can be correct. Okay, it's a multiple choice question. Everyone, please come up with the correct answer. I'm giving you 60 seconds. I think now a few ML questions have started coming up. So generally what happens is these questions are not given together, right? Only one will be given. But because I'm trying to cover as many concepts as we can in this short series, so my intention is that if I can make one question with all of these problems in it and make you understand, then that will give you the best benefit out of it. That will give you the best revision as well. And we could cover more things, right? So 20 seconds left. Everyone, please answer. What are the problems with k-means clustering? More than one can be correct. So Rishabh says A, C, and D. All right. So that's the wrong answer. I believe all of them are correct. All of them are correct. All right. So sensitive to outliers. First problem, definitely k-means clustering is sensitive to outliers. Now, how is it sensitive to outliers? In the worst case scenario, I'll explain you with the worst case scenario. Let's say you choose an outlier. Let's say your entire data was in this cluster. All the data was in this cluster. You choose a centroid itself as an outlier. Then imagine what will happen, right? This cluster will have nothing in it. And maybe one more centroid that you initialized, that particular will have one more cluster. But ideally what you wanted was, let's say that you wanted that you have at least 2 clusters in this so that you can differentiate very well. So outliers is definitely a big problem when it comes to k-means clustering. So it is sensitive to outliers. It is a problem. Centroid might be difficult to interpret. Yes, because in k-means clustering, my centroid is mean of all the data points. Mean of all the data points. So in this cluster, whatever data points will exist, the mean of these data points will be my centroid. And that does not guarantee that my centroid is actually a real point. If in case it was a real data point, a data point that was coming out of my data, it would have been more interpretable. And because a centroid in this case is actually a data point that does not even exist in my data, it's occurring because of a mean that I'm taking. Hence, yes, centroids might be difficult to interpret. So option A, option B, both are correct. The solution for this is to maybe remove outliers. That is the best solution. The solution for this is k-medoids. Now let's talk about C. So only works best when clusters are homogeneous and convex. That's, yes, again a problem. Now why is it a problem? Let's take that the clusters in reality were two concentric circles. K-means cluster can never give you this. Because how it works? It says, okay, one my centroid is here. So K-means will say, okay, this data belongs to first centroid. And this data belongs to the second centroid. Let's say the second centroid was here. Anywhere you initialize, K-means clustering cannot give you heterogeneous or non-convex clusters. It cannot give you these type of clusters because it is based on a distance-based algorithm. These kind of clusters you can attain from different algorithms, for example, dbScan. And hence, this is again a problem that occurs with K-means clustering, and C is the correct answer. Moving to the last and the D point, that K-means clustering does not avoid noise. And this again is the correct answer because K-means clustering, even if it is an outlier, it is an anomaly, let's say it is a noise, it came because of some randomness stupidity that we did in the data and we got that outlier, which is entirely a noise. K-means clustering, if let's say let's say I initialize my centroid here, another centroid here, right? So in this particular cluster, I will still have my centroid. K-means clustering will not ignore any data point. Then what will happen is, after this, from here, my centroid will move to here. So this is an outlier, right? This is an outlier, right? So after from my center, my centroid will move over here. Eventually, I will end up with this cluster only. And this will become one cluster, right? With centroid somewhere over here. Eventually that will happen. So because of this noise, it's causing such havoc. The reason is because each and every point it considers as important. It will not leave any point which it feels should not enter into a cluster. What would another algorithm like dbScan would have done was, let's say there is, and I'm just drawing a few data points. What it would have done is, and a point over here, it would have made a cluster of this and left this point, would not have assigned this point to any cluster. And hence, this noise would have not came into place in my decision making or into changing the way my clusters are built or changing the shape of my clusters. And hence, because K-means clustering does not avoid noise, that is again a problem. Therefore, options A, B, C, and D are correct. Also, I've mentioned a few things that are the solutions for these. You can have a look at that. One more very important problem of K-means clustering is that initialization is not always the same. Probably we'll touch on it in the upcoming test prep sessions. All right, now moving on to the next particular question. If you have any doubts, please feel free to ask from me. As you can see, all the options are correct. All right, a bit of expected value and probability is what I'm seeing now. Uh, 60 seconds will be too less for this. Let me give you 120 seconds. All right, everyone, please come up with an answer. We are halfway done. Today I can see that we are going on time. It's good if you know, Harsh, especially linear regressions, gradient descent algorithm. It's good if you know how to code them from scratch. It is definitely asked in few of the interviews. But only do linear regression, gradient descent, that's more than enough. You don't have to do decision trees and all of that. All right, everyone, 55 seconds left. What is the answer, folks? Time is ticking. Yes, correct answer. Correct answer is A, 7.5. "25 more seconds for the rest of you. To solve it. And once you've solved it, now because I've already told that A is the correct answer, you can put it that you've got it. If you've not got it, let me know. Alright, time's nearly up. Now I'll be jumping into the explanation. The correct answer is A, 7.5. So what is it saying is, let X be the number of heads in 3 tosses of a fair coin. Okay, define a new variable which is yx square. What is the variance of y? This is what we need to calculate. We already know that variance of y is nothing but ey square minus e of y whole square. Right? I hope you all know this. Yes. Now let's first make the distribution, how the distribution would look like. So we know this is nothing but a binomial distribution. And if it's a binomial distribution, then 0 heads, 1 heads, 2 heads, and 3 heads is what I will get. One second, just let me clear it a little bit. So these are the values of x that you can get. What is the probability of these x? Can you calculate, everyone, and tell me? What is the probability of these x? What are the probabilities? It's a binomial distribution. What is the probability of getting 0 heads? What is the probability of getting 3 heads? What is the probability of getting 1 heads? Can you please calculate? So n will be nothing but 3. For the first one, k will be 0. P is 0.5, right? So I think it will come as 1 by 8. Correct me if I'm wrong. 3c3, 0.5 raised to the power 0, 0.5 raised to the power 3. And the answer would be 1 by 2 raised to the power 3, which is 1 by 8. So 1 by 8 will be for this, 1 by 8 will be for this, 3 by 8 will be for this, 3 by 8 will be for this. Because it's a symmetric, as my P and Q are same. So it is a symmetric algorithm. I can make the rest of it on my own in quick steps. Now I'll wipe it off. 1 second. I'll just quickly. Okay, leave it for now. We have enough space. Ignore this. All right. Now what will happen is I can also create a y out of this. So y, which is nothing but x square, will be equal to what? In 0 it will be 0, in this it will be 1 square 1, 2 square 4, and 3 square 9. Now y is just a square, but the distribution of y is not changing. The distribution of y, is it changing? It's not changing. The probability and the distribution is entirely the same. And hence how I can calculate E of y is pretty simple. I would just say E of y is equal to nothing but y multiplied by P of x, summation for all values that y can take. Or basically I from first I is equal to 0 till 3. Now for I0, y will take what value? For I is equal to 0, y will take a value of 0. So probability does not matter, it becomes nothing. Then 1, so 1 into 3 by 8. Then 4 into 3 by 8, which is 12 by 8. Then 9 into 1 by 8, which is 9 by 8, which comes out to be 12 plus 9, which is 21, 21 plus 3, which is 24, 24 by 8, which is nothing but 3. So E of y comes out to be 3. You can calculate it, Rishabh. It's exactly, it will come to the same thing. You can calculate it. Because P and Q are same, so it will be a symmetrical distribution, and hence I could have written it out easily. You could have calculated it yourself if you want to. So now what do I need is, I need to calculate the variance of y, which is nothing but e of y square minus e of y and whole square. So this I've already gotten as what value? I've gotten as 3, and take a square of it will make it 9. Now what about my ey square? Expected value of y square will basically mean nothing but we have to take a square of it. Again, the distribution is not changing. There is no change in the distribution. This will become 0, this will become 1, this will become 16, this will become what, guys, everyone, what will this become? 81? Yes or no? Yes or no, everyone? Will this become 81? Yes or no, quickly? What is the addition of this? So adding this, I would get 17 plus 81, which is nothing but, 1 second, 98, and I would divide it. Okay, 1 second, I missed something. I think I missed something. Yep, sorry, I forgot to multiply it with the properties. So y square multiplied by p of x. Now this will become 0 into 1 by 8 plus 1 into 3 by 8 plus 16 into 3 by 8 plus 81 into 3 by 8, 1 by 8. And when you add all of this, what will it become, everyone? Take your time and calculate if you feel like. So it would be 16 into 3 plus 80, 81 and 3. Can you tell me what the answer would be from here? Hurry up. Waiting for your answer now. Now you can calculate it at least yourself. You've done everything. Please calculate it and now come up with the answer so I can move it with the next question. I will not be solving the entire calculation. You should do it yourself. All right, 16.5. Good job. Yes. So this will come out to be 3 plus 16 into 3 plus 81 divided by 8. And then this will come out to be, I think, 132 divided by 8, which will be 16.5. So you will put 16.5 over here, and 16.5 minus 9 will be your answer, which is nothing but 7.5. Correct. All right, so these kind of questions you might see very commonly, especially in the banking exams. Why is there a distribution? Isn't p of x entirely the same? When the p of x is entirely the same, there is no change in the distribution. I mean the distribution in terms of probability. Is there a difference in probability of those values? No, right? So you can directly take p of x with y square, right? You could have directly taken y into p of x, right? These things you could take directly. You don't have to again calculate all of those because they are not changing, right? So that is what I mean, that the distribution is not changing. So why are you changing it? Why is there a need to basically recalculate those? Okay. Now let me clear the screen. If you have any doubts, please feel free to let me know. This is a very common question when it comes to banking exams and quant profiles. Not banking exams as in the bank exam, basically data analyst and data science roles for companies which are banks, right? That is what I mean. Not the banking exams, I'm sorry. All right, now let's move on to the next particular question. Question number 9. Let's try to solve this question. Okay, answer A is correct. Not always, Rishabh, you need to see it. That's what I said. In this particular case, there were not many different things happening, right? In this particular case, there was not much changes. It depends, not always. We might go much deeper down in it someday in this session. All right, for your 6 I rolled, you get twice the face value. If the outcome is odd, you get the face value minus 1. What is expected? Okay, pretty simple question. 60 seconds is all I think we would need to solve this particular question. Still, I would just give you 100 seconds. Please solve this particular question. Come up with an answer. There are only 5 more questions remaining. One, as always, will be the homework that you guys have to do. I'll be sharing the slides within here. Okay. These expected value questions are generally, if you are from mechanical branch, you would study for sure. Expected value and variance, you would generally study. But if you're not from these branches, for example, I was from biochemical, I never studied this in college, right? So, but these are very important, specifically for interviews, very, very important. And especially for those companies where, for example, bank companies, whatever the banking organizations will hire you, they ask these kind of questions. And also quant. And a few companies which are highly based on probability, they also ask these questions. All right. I don't know the answer yet. I have to still calculate. $20 more seconds, everyone. Okay. All right, 10 more seconds, everyone. I'll give you extra time if you're still solving it. This one is pretty simple compared to the last one. It's a pretty simpler question compared to that one, right? All right, so you guys are getting B. I am not sure. I don't remember the answer for it. We need to calculate. All right, so what is happening is, let's look at it now. I think enough time I've given. All right, so what is the die phase? So phase on the die is, let's say 0, 1, 2. It will not be 0, obviously. Sorry, my bad. I don't know what I'm doing. Right, so it will be 1, 2, 3, 4, 5, and 6. Then after that, you will have whether the phase is even or whether it is odd, right? So this is an odd, this is even, odd, even, odd, even. As simple as that. I hope you guys understand. Now what the question is saying is, from here it starts, that the face value minus 1 will be the payout. Face value minus 1 will be the payout if the outcome is odd. And if the outcome is even, you get twice the face value. So basically they're giving a payout to us. If the face value is even, then you get f into 2 payout. And if it is odd, then you get fo minus 1 as the payout. Then you would have to just find the expected payout, which is the average payout, right? So expected value is nothing but the average payout. So how would you do this? You will say, okay, even and odd. Over here, 1 minus 1 will be your payout. That is 0. Here it will be 2 into 2, which is 4. Then here it will be 3 minus 1, which is 2. Then 8, then 4, then 12. So now you can just simply take an average of this. You can say 1 plus 4 plus 2 plus 8 plus 4 plus 12 divided by 6. And, 0. 0 plus 4 plus 2 plus 8 plus 4 plus 12, which is, you can see 10. And then we have, after this, 1 second, I've done it correct, right? Yes. This will be 8. This will be 30. 30 by 6, which is nothing but 5. 5 is the answer. You can calculate the average directly. The reason being because probability for all the dice faces are same. Otherwise, you could also have done 1 into 6 plus 0 into 0, 1 into 6 into 2, 1 into 6 into 4, sorry. Then 1 into 6 plus 2, 1 into 6 into 8, plus 1 into 6 into 4, plus 1 into 6 into 12. You would have done this entire nonsense, but it was just a waste of time, right? It was barely 60-second question. I took probably 2 minutes, 2.5 minutes to explain you, but it was barely 60-second question. If you could have easily said, okay, it would be nothing but, for first one it will be 0, then it will be multiplied by 2, 4, then it will be 3 minus 2, that 3 minus 1, which is 2, then it will be multiplied by 2, 8, then it will be minus 1, which is 4, then it will be multiplied by 2, which is 12, divided by 6 is the answer, and that will come out to be 5, right? You wouldn't even have to write all of this. This was just, I was writing it down to explain you guys, but this was a very simple, very fast question that you could have done, right? So 30 by 6, which is nothing but 5. Easy one. All right. But in case, let's say the dice was an unbiased dice, right? In case the dice was an unbiased dice and the probability for each, let's say, was proportional to something. For example, I'm just giving an example. Let's say it was 1 by k. K is the face value. Let's say something like that occurred, right? Something like that happened. So then you would have to go through this entirely. You cannot just simply take an average. Either you take a weighted average or you go with the proper definition that E of x is nothing but P of x, x into P of x. You go with this proper definition, right? And here are, this is the payout. So E of P and multiplied by P of, which is P of payout multiplied by payout, right? This is what we did. All right, so please be sure that you are not stuck in this trap. Now I'll move on to the next particular question, a pretty simple question, this one. You can see 5 is the correct answer. All right, so question on ML. I'll give you only 60 seconds for this. A pretty simple question. I think it's based on some elbow method. Four more questions after this, everyone. Let's quickly hurry up, make the best out of it. I recently saw this question somewhere in some company test. Very recently. Why is the elbow point often selected when determining the optimal number of clusters? K in K means. All right, 10 more seconds. What is the answer, everyone? What is the correct answer? Time's up. So according to me, the correct answer is, 1 second, I'll just clear the screen. A. So because, let's look at this, there's no Lloyd's algorithm in it. So this is the wrong answer. Inertia reaches a global minima at this point, ensuring both intra-cluster tightness and uniform cluster size. So this is also entire nonsense. This elbow method does not tell you about the uniform cluster size or intra-cluster tightness. It does tell you about intra-cluster tightness, but does not talk about uniform cluster size. So again, this is entirely nonsense. Because the elbow method maximizes inter-cluster distance and guarantees cluster stability under reinitialization of centroids. Maximizes inter-cluster distance. So elbow method is actually based on WCSS. It does not talk about inter-cluster distance. It's not different clusters, the distance between them. It talks about the intra-cluster distance, and hence this is also wrong. So the only option correct is A, right? Only option correct is A. Now let me explain you actually a few things about elbow method. So basically, let's say this is WCSS. This is number of clusters. You get a graph like this. I couldn't draw a proper elbow. All right, just let me clear it. Not happy with my drawing. I'm like, I already suck at it, but yes. Anyways. So this particular point is looking like your elbow, right? Picasso drawing, right? Looking like an elbow, right? This particular point. Yes. This is called as the elbow. And you will plot it versus WCSS and K. And this is your optimal number of clusters. This particular point is your optimal number of clusters. This particular point is the optimal number of clusters that you need to think of, that you need to basically take. Now, why you need to take this point and why not maybe this particular point? What exactly is WCSS? So WCSS means within cluster sum of squares. So basically within a cluster, what is the variance of the points? So you calculate the cluster mean. cluster mean subtracted by, it should be opposite, by all the data points in that particular cluster. You take the square of it, take summation for all the x's belonging to cluster C, for all the data points belonging to cluster C. If you carefully look at it, it is kind of nothing but the, what? It is looking like nothing but variance. It is telling you about the variability within a cluster. Then you take an average for all the clusters. This will be for cluster 1, then you take for cluster 2, then you take for cluster till cluster k divided by k. This is something you will do, right? So this will tell you what is the variability inside a cluster. And what do you ideally want? You want that each cluster in itself has low variability. But different clusters compared to one another, clusters compared to one another should have more variability, but within a cluster, within one cluster, the variability should be low. The variability should be low. And because you want the variability should be low, your WCSS should be low. Then a very important question comes that it is still decreasing. Then why do we only choose this particular point, which is the elbow point? Because after this point, the decline in WCSS, if you see, let's mark a few clusters over here. K1, let's say K is equal to 1, let's say K is equal to 2, 3, 4, 5, 6, 7. So the optimal number of clusters will be K equal to 3. From 1, the decline in WCSS was this much. The decline in WCSS was this much. For 4, the decline was a bare. I cannot even draw. For 5, I cannot again draw it. For 6, I cannot again draw it. For 7, it is again very less. I cannot draw those. But every time I am creating one extra cluster, I am increasing the computational complexity, because all the data points apart from the centroid, you will be calculating its distance. So you will be calculating n more distances by adding one more cluster, increasing the computational complexity while building them, plus at the same time, you will also be increasing the computational complexity while calculating them, while calculating the metrics and doing the analysis. So here's a trade-off, that within clusters, sum of squares, when it is decreasing, your complexity computationally is increasing. Computational complexity is increasing, and hence we say that below this point, there is not much decrease in WCSS that can compensate for increase in complexity, and hence I will stop here. I will not go for minute WCSS decrease, but increase my unnecessarily computation complexity. This is called as the point of inflection as well. A terminology, even if you don't remember, that's completely fine. मेरे को खुद नाम नहीं याद रहते. It's completely fine even if you don't remember. One more point over here is, some people also refer this particular point as that if you go beyond this point, kind of it is like overfitting. You are maybe learning the noise and overfitting your clustering algorithm. Some people refer to it like this as well, even though even I know that clustering does not have any sort of error. But it's a terminology that is a lot of people use. Some people call it as over-partitioning. But here, understand, A is the only correct option. It is saying exactly the over-partitioning thing, the extra over-partitioning that we are doing by only taking minor decrease in WCSS. However, in the second one, we are talking about inter-cluster distance, which is actually calculated using BCSS, between cluster sum of squares. We are not talking about intra-distance. So this is wrong. See, because inertia reaches a global minimum at this point, there is no point of inertia first of all here. Intra-cluster tightness, yes, we are talking about, but uniform cluster size, we are not sure whether the cluster sizes are uniform or not. That we don't know. We might be taking cluster sizes as, let's say, one is this much and another is a big one. We don't know what is happening at that particular K. At that particular K, we are not sure. But yes, when K increases, then what is happening is we are sure that our clusters Imagine when k is equal to n, right? Then every data point will have a cluster of its own. So yes, we are going towards that, but that is not what we are trying to achieve. Hence, this is again a wrong point. Then the last point, there is no Lloyd's algorithm in this, right? So A is the correct answer. Only the language was tough. The solution was pretty simple. I hope you guys are clear with it. Now I'll move on to the next particular question. We can see A is the correct answer. Moving on to 11th question. All right, a pretty simple question. This one I think we put in because you have been talking a lot about regularization in the first few prep sessions, test prep and interview prep both. So kind of like a revision question. If you can answer it. Thirty more seconds, everyone. After this, there are three more questions, 12, 13, and 14. So hold on till a few more minutes, everyone. Okay, so I'm not seeing any answers so far. But the time is up. I'll give you 10 more seconds. Right, so the correct answer is because the constraint region of L1, which is Lasso regularization, forms a diamond, right? So that is the correct answer, which is B. Yes, Rishabh, that is the correct answer. Now, what do we mean by sparse model? L1 regularization, I hope you already know that is nothing but Lasso regularization. Sparse model means model which has less dimensions. Less dimensions means less input features. And how can you get less input features with Lasso? Because Lasso performs feature selection. If in case directly it was mentioned feature selection, you could have just ticked on feature selection. But now the reason of feature selection is because the constraint region of L1. So basically what happens is in Lasso regularization, this is a region. This is the regularization region, that is your beta 1 plus beta 2 plus beta 3. Let's take only two coefficients, beta 1 and beta 2, right? So they are less than some value t. This is what you consider. One solution is basically this, and this forms a diamond like region. You have a diamond like this, right? Then your OLS is contours. OLS is nothing but contours. So wherever the OLS meets that with the constraint region of the regularization is your solution. Because it is a diamond region, they might meet at these edges. If they are meeting at these edges, that means if they meet over here, that means beta 2 has some value per beta 1 equal to 0. Here it means beta 1 has some value but beta 2 equal to 0, right? Similarly, if it meets here, that means beta 1 is equal to 0, beta 2 has some minus value. Similarly, if it meets over here one of the contour, then it means beta 1 is equal to minus something and beta 2 is 0. And because of this, the feature selection happens, and it therefore is because the constraint region of L1 forms a diamond. In case of L2, there is a spherical, and because there are no edges here, the contours actually do not meet here. They might meet inside the region or on the surface, and all these will be the solutions. And hence there is no feature which is actually taking a value of 0. No, basically if your coefficient is 0, that means the feature is not being taken. Your feature is not being taken, which is feature selection. And because in ridge, your L2 regularization, there is a spherical constraint, you might not pick the values. You will not pick the values definitely from the edges. You might pick it from the surface or from this place. Basically, when I mean the surface is inside this constraint, right? Inside this constraint, because that will be nothing but circle and also less than t. So all the values, all the region inside the circle as well will be considered. right? So here, because there are less chances there are no chances that the contour will meet on the edge, and none of the features will ever be zero. Here there are chances that the features will be zero because contours might meet the edge of the diamonds, and hence B is the correct answer. All right, this was a pretty simple question. If you understood how does the feature selection of lasso and ridge work like. Now let's move on to the next particular question. We can see B is the correct answer. All right. "60 seconds. Please answer it, everyone." After this, only 2 more questions. I hope you are also calculating your score meanwhile. What is your score? Only take the marks if you're solving it within the given time span. That will give you a clear indication of how much you are lagging in terms of time and also in terms of accuracy. Ten more seconds. Rishabh has put in the answer. All right. So time for the answer, everyone. The correct answer is B. If beta is greater than 1, then you are preferring recall. It is as simple as how, because when you derive F beta score, you say that when recall upon precision is equal to beta, then my partial differentiation of F1 score, F beta score, divided by precision, F beta divided by recall, is same. Basically, when you derive it, you say that recall divided by precision is equal to beta. At this particular point, a small change in precision and a small change in recall will lead to equal changes in my F beta square. A small change in precision or recall will change equal changes in my F beta score. This is how you derive it. And hence here it's clear from here that if beta is greater than 1, that means recall is greater than precision. And hence answer is B, recall sacrificing precision. I hope this particular question is clear. Once you derive it, then you will get the F beta square. With 1 plus beta square, precision recall, beta precision plus recall, beta square precision plus recall, all that score, all that formula you will get once you have completed the derivation from here. You don't have to worry about the derivation, but it's important that you understand what happens when beta is increased. So when beta is greater than 1, recall is increasing. When beta is less than 1, then precision is being promoted more. So B is the correct answer. Now let's move forward to the next particular question. Okay, my mistake, I put a question in between. So recall sacrifice precision is a correct answer. Now moving on to the 13th question. Okay, so because there is a question in between, let's also solve this extra question. I'll give you 60 seconds to solve this. Let's not leave this question. We found an extra question, a treasure hidden in between. 60 seconds is all you have to solve it. I think even 30 are more than enough. Alright everyone, Abhishek, Achintya, Rishabh, Rutvika, Harsh, Shivangi, Manas, what are the answers, guys? Pretty simple question. Correct answer, Rishabh. कल की क्लास में किया था. All right, time is up. So in reality, again to emphasize, in reality, all of this is nonsense. You can never tell whether bias will increase or variance will decrease. This is a huge debate in the industry. Hence, this question at all does not make any sense. Some people believe that bias increases, some people believe that bias decreases. This is a question of utter nonsense. If it's a huge debate in industry, I don't know how can I teach you this. But because this question is here, and you might see these questions coming in your placements, let me tell you the most widely accepted answer that we can go with. I don't believe in that answer because of the research papers that I've gone through. But even if this comes up in a terms of question to me, I would have to answer it, right, in this manner only. So bias increases, variance decreases because of the most widely accepted answer. Now let me tell you about the most widely accepted answer. So let's assume we have 1000 as training data. I take a k is equal to 5. I take a k is equal to 10. So in this, my fold size will be what? Fold size will be 1000 divided by 5, which is 200. Therefore, training data will be 200 into 4, which is 800. And testing data will be nothing but 200. When k is equal to 10, my fold size will be nothing but 100. Therefore, my training data will be 900. And my testing data will be nothing but 100. So as my k is increasing, let's talk about decreasing because that is given the question. So as my k is decreasing, my training data is decreasing. And when my training data is decreasing, I am saying that there might not be all the patterns present in this training data. Because of this, I'm training a model on very simple patterns. I'm giving model the data that is very simple. I'm taking a simplicity assumption, because of which my bias is increasing and my variance is decreasing, leading to underfitting, and hence 1 is the correct answer. However, this is something that I do not believe in. If you have any doubts, you can ask me. Otherwise, I will go on. And as you can see, once more I'll emphasize, training data is decreasing when k is increasing, right? When k is decreasing, when k is decreasing, training data is decreasing, right? So because of this, there is underfitting, because there might be not all patterns that are visible in here, right? And because of this, bias is increasing and variance is decreasing. Again, I don't believe this. There might be another way as well. All right. Think about it in terms of test error. In terms of test error, if k is equal to n, then the test error will always be the same. There is no variability in it. Then what is happening? When k is increasing, variance is decreasing. When k is decreasing, variance is increasing. See the opposite of it. See the opposite of it. All right, not go much into the opposite of it. The other demand, the other industry debate on it. Let's move on to the next particular question. All right, question number 13, based on logistic. I will give you 60 seconds to solve this answer, to get to the answer. I want to see answers, everyone. This is a pretty simple question. Shivangi, Abhishek, Rishav, all of the guys and girls present here, I want you to answer this second last question of the day. Pretty simple question. All right, time is up. B is not the correct answer. We are talking about maximum likelihood function, not the final cost function. That is the wrong answer. B is the wrong answer, everyone. Take last guess. B is the result of MLE. B is the result of MLE. All right, so the correct answer is A. Good job, Rishabh. The correct answer is A. Let me clear the screen. So I will not go into the entire definition of it. That will take a lot of time. Entire derivation of it. That will take a lot of time. The correct answer is A. And why is it A? Because you say that MLE is nothing but likelihood function, and this maximizes, it finds a probability distribution that will maximize the chance of that event occurring. So in case of logistic regression, we are doing binary classification. So what does MLE do? So MLE tries to give you a distribution which maximizes that, let's say our data 1 belongs to class 0, data 2 belongs to class 1, data 3 belongs to class 1, and so on. It tries to maximize this particular event by finding a distribution which will give this the probability of these events to be maximum, which will cause the probability of this particular events happening to be maximum. In this case, you do not know the distribution. You are looking for a distribution that will give you maximum probability, and hence the MLE function is nothing but L of theta, which is the probability of my data belonging to a particular class, which can be 0 or 1, given the data, a conditional probability. Given the data X, which class should it belong to? Now there are two classes that I need to incorporate, which is class 0 and class 1. Now let me clear the screen. So py equal to 0, given some data, that is data X belongs to class 0 and then is data belongs to class 1, given and hence basically these are conditional probabilities because the data is given and then only they will belong to some class, right? So these are conditional probabilities that you will use. Now because there can be only one probability distribution, so you need to incorporate them together so that you can create maximum likelihood function, which is L of theta, is nothing but probability of some class Y given my data point X. How can you incorporate this together? So we know that py 0 given X is what? This is, let's do this first. This is nothing but Y predicted, and Y predicted is the probability that data point belongs to class 1, which is nothing but sigmoid function and then whatever linear regression will there be for ith data point. For ith data point, whatever linear regression will there be for ith data point, right? And probability that it belongs to class 0 will be nothing but 1 minus Y pred, which is nothing but 1 minus sigma, which is not sigma here, it is a sigmoid function. This is a sigmoid function, and bt x of I. Now I need to incorporate this in 1. So what I can say is p of y equal to 0 given x multiplied by p of y equal to 1 given x. But this way I'm saying that the probability distribution will try to assign this data point to both the classes with some probability. But that is not what I want, right? What I want is If the data point is of class 0, I only want this probability. I don't care and don't want to worry about the probability of it belonging to first class. Let's change it a bit. Let's make 1 and 0 so that answer is in the correct format. It is the same. I'm just making it change. Just a multiplication, right? It's commutative, right? Nothing changes. Nothing changes. Now, what will happen is, what can I do is, I can write the y and 1 minus y for it. And this will be my y true. Y true. So if in case my data truly belongs to class 1, then I want this probability to be maximized. In case y true is 1, then I will get py is equal to 1 given x. Only this will become 1 minus 1, 0, and will become 1. And in case my y true is equal to 0, then I want only this probability to be maximized. So it will become py equal to 0 given x, and 1 minus y will become 1, and only this will be taken. This will become 1 minus 0, which will be nothing but 1. This will become 0, and hence will be becoming 1, will become 1 entirely. So this is the probability that I'm telling my MLE to maximize. This is the probability that I'm telling my MLE to maximize. And that is the MLE function. And you do it for all the data points. And because you will say, I want to maximize the probability for data point 1, for data point 2, belonging to y, belonging to y, belonging to y. And we know that all these data points are independent of each other. So it will become y divided by d1 multiplied by y divided by d2 given d2 multiplied by p of y given d3. This is what you will get. And hence, you will do a product of all the data points. Then you will take py is equal to 1, which is nothing but sigmoid function, and y predicted. Then you take y actual over here. Then you take y0, class 0, py equal to 0, given x. So you will take 1 minus sigmoid function of linear regression. And then above you take y true, 1 minus y true. This when you maximize. And this is what you need to maximize to get the probability distribution. But to make it much more simpler, you can take a negative of it. Then the problem will be to minimize it. And after this is when you can optimize and come to this particular B answer. So this is the entire MLE function that you need to be careful of. All right. This is the exact MLE function. This is after the outcome of it. Once you've put in all the values, taken the log. So basically you will also take a log. After taking the log, it is not MLE, right? It is log of MLE. So hence this is the wrong answer. I hope it is clear. This is not MLE. This is log of MLE. Then after this log, you will take, first you will take a log. Then after this, you will take a subtraction. Then you will run a gradient descent algorithm. And this will become your log likelihood. This is log likelihood function, guys. If there is a minus over here. This was log likelihood. This was MLE. All right. I hope it is clear. If you have any doubts, please let me know. This is how the derivation of log likelihood works. Very important for placements. Very important if you want to be good in data science and data analytics. Anybody can tell you the log likelihood. Even if I teach a 6th standard student machine learning, that person can also learn log likelihood function. But how does it come from? What is MLE? Where does it come from is the most important aspects that will make you a good data analyst or a data scientist or a good data professional. If you do not know this in logistic regression, it's high time you go and learn it. All right, 14th question, the last one. I'll give 60 seconds. Pretty simple. If you know it, you know it. If you don't know it, you will not come to the correct answer. All right. So time is up. I think I've given you enough time, everyone. So the correct answer is D. ROC-AUC curve is not meant for imbalanced data. For imbalanced data, you should use PR-AUC curve. And that is the correct answer, D. I might go into much depth of it some other day, not today, when we are properly talking about metrics, but not today. So just a bit of understanding that ROC-AUC curve is based on sensitivity and specificity. PR-AUC curve is based on precision and recall. They are better metrics to gauge the imbalance in data, and hence a precision recall curve is a better metric, will give you a better AUC, a more credible AUC when your data is imbalanced, and hence you will take PR-AUC curve. Because the other one only talks about true positive and false positive rate. This will talk about both false positive and false negative. ROC talks about only true positive rate and false positive rate. This one talks about both. So both are important. All right. Now, let me share these slides to all of you. Just give me 1 second. But first, before that, please note down this is your question. Please take a screenshot of it that you need to solve. All right. I hope you all have taken a screenshot. Cool. So a lot of people have been actually asking me in DMs, some of you who attend the session, that is there where can we get the questions from? So the answer is we actually have we keep a test series that is at a very minimal cost, gives you 90 tests and covers all the questions from ML, DL, statistics, aptitude, SQL, Python, all of these are covered. So if you want to, are you interested in the test series? You want to join the test series? I'll share a link with you. You can look at it. If you like it, you might join it later on. If you are interested in it, it will be good for you to keep, and if in case, let's say you are a bit worried about the finances, we will help you. Don't worry about it. As long as you're interested, that's the case. That's all I need to be thinking about. All right. So I'm going to share you 1 second. All right. I'm going to send both the links here. All right. So this is the test series that you can look at, and this is the test prep session. Slides. In case you need any help, please feel free to DM me or our team. Thank you all. And if you are here for the first time, if you liked it, please don't forget to just subscribe it, right? Whatever that button is, please click on that. That helps the team more than me. It helps the team be motivated towards keeping these sessions and helping you all. Tomorrow I'll meet you with an interview session. I hope you have a good day and you make the best out of it. Take care and have a nice weekend.